Alright, so now we're going to talk about Unit 10, Section 9, and angles formed within a circle, or around a circle, or about a circle, formed by tangents and secants around that circle. If you recall, a secant, we talked about it in 10.8, a secant is a line that intersects a circle in 2 points, anywhere in those 2 points, and a chord is, the line segment within that circle, right? The chord is like the chord of a bowstring, if that helps you remember. It's actually literally where the term chord comes from. So this is the secant. Secant. Blue letter is chord. Blue is chord. Right, and then a tangent, if you recall, from way back in 10.0 is the one I made up, and then 10.1 I think we talked about it a little. We had a tangent is when we have a line that comes and just clips the circle in one spot. Just clips the circle in one spot. Right, so 1 point, one of those points of infinite number of points. Tangent. One of those infinite number of points that make up the circumference of a circle. Because remember that that radius, the circumference is made up of a circle by the radius. By the radius making a bunch of points, infinite amount of points, one radius away from the center, and that's the radius. Okay, so something interesting to note about the tangent. The tangent will always intersect the radius at a 90-degree angle. So that's something that's kind of neat. You're always going to have the tangent intersect the radius at a 90-degree angle, and that's something you cannot say about the secant. There's all sorts of different angles that there will be some radius that intersects the chord at a 90-degree angle, but maybe not the radius shown on the drawing. Right? But there will be a tangent and a radius that intersects at 90-degree angle. Okay, so this is a 90-degree angle. All right, so that's kind of neat. And let's see if I want to show it on this one. I'm not going to show it on this drawing yet. All right, so those are the different things in one relationship that I wanted to point out here. Okay, so when you have a, let's see if I need to readjust so I'm not writing on that crack on my desks. Okay, there we go. So if I have a tangent, there's two scenarios that happen when you have two tangents. You have one tangent meet over here, one tangent intercept, right? You have a tangent there, and then you have another tangent. Any tangent, you see, any one of these could be a tangent. Any one of them, we'll say this one. Say this is a tangent, right? This tangent, and they intercept outside the circle. This tangent and this tangent, they intercept, and they will intercept outside the circle. Okay, well, similar to the last 10.9, you might see a similarity between something that happened last time. So let's find ourselves like a general center of a circle. Well, you see that there's two arcs that are made. We'll say that this point here, we'll say this is center C of a circle. We'll call this center P for like point of intersection of our tangents. And then we're going to call this point A, and we'll call this point B. Okay, and then we have a minor and a major arc, and so that we can identify the major arc, we'll call this point Z. All right, so I think we've identified enough stuff here to prove or to discuss my first concept. Okay, so like I said, a tangent is a line or a segment that intersects a circle at exactly one point, right? And we already talked about if a line is a tangent to a circle, then it is perpendicular to a radius, which ends on the tangent. That's what we talked about right here. Okay. Okay, so now we have this line segment. What color did I use last time? I used R. I used this angle right here, and I named this, I've been using this as capital gamma. Capital gamma is this angle out here, which is equal to this angle because it is vertical in nature, and this angle is supplemental to this angle way out here outside the circle. And then inside the circle we have our angle, which I've been calling, what color was I using? We'll do blue, because we use the radius for blue. We have our central angle in here. Just kind of identifying all the different angles in here. We have our central angle. I'm going to erase this to make it a little neater here. This is our central angle at point C. I've been naming this psi. And we have an inscribed angle. Why not? We'll name this inscribed angle over here. What color should I use this one? I'll use orange. Sure, I'll use orange in my example over here. And we have an inscribed angle over here too, which is kind of neat. All right, no matter where I put this angle, this point Z, no matter where I put point Z on here, all right, this angle would be inscribed. And I'll call this angle omega, because Greek letters are cool. We got omega. I avoided theta because I don't have any right angles, right? At least I didn't say I had any right triangles in here. I like to use theta for right triangles. Anyway, so I got these three angles, and I don't know if I'm going to get to using them today because I want to talk about this angle and the relationship of this angle to everything else. Okay, I've discussed these angles already. Okay, so we have some arcs here. Let's talk about the arcs that we have. We have arc, major arc, AZB formed. Major arc, AZB. Okay, that's major arc, AZB. That's major arc, AZB. Okay? And then we have a minor arc formed. Remember, we call that a major arc because it's got three letters. And then we have minor arc, and I'm going to use, what color do I have in this ink? I have a red. I'm going to use minor arc. I have minor arc AB. I have minor arc AB here. AB is my minor arc AB. Minor arc AB. Okay? So that's my minor arc right there. Okay? So I've pretty much identified all the stuff inside of this circle here. So the relationships. The relationship between this arc, and our angle theta, they're the same, well, not angle theta, I'm sorry. We'll just talk about the arc angles here, because that's what the topic of this conversation is. The topic of this conversation is, what is the relationship between our gamma capital gamma. Looks like a Grim Reaper psi kinda. Okay, and our arc angles. Well, it's very similar to the 10.8 to the 10.8 relationship. Well, there's a major arc formed and a minor arc formed. Well, the major arc formed is AZB, right? So the major arc is going to be what we're going to start with. It's AZB, and then the minor arc is AB, and it's going to be the difference between those two divided by 2. So this angle is the difference between the arc measure of the major arc and the minor arc divided by 2, or this big arc minus the little arc divided by 2. So for instance, say this thing was 220 degrees. Since this is a full circle, right, that means that this would have to be 360 minus 220, right? It means that this would have to be 140. So this is 140, right? So this would have to be 220 minus 140, right, divided by 2. So this would have to be, I said 220 minus 140 divided by 2 equals, this would have to be 80 degrees. This would have to be 80 degrees. So this would have to be 100 degrees out here, because this linear pair equals 180. I wrote 180. That should be 100. That should be 100 degrees. That worked out pretty nice. That should be 100 degrees there. Right? So we know that if this arc is 220, right? Then let's go ahead and finish what we don't know here. Let me zoom in a little. So if this arc is 220, we know that this big central angle, right, angle ACB, right, or 360 minus psi, right, is 220. So we know that measure of angle ACB, the big one, is 220. And then the angle psi is this one, is 140, equals 140 degrees, right? And then if you recall, to measure the inscribed angle, this one here is going to be 1/2 of the central angle. So this angle is going to be 1/2 of 140. So omega, I'll do it right here, omega equals, AB divided by 2 equals 140 divided by 2 equals 70 degrees. That's kind of cool. We figured out a bunch of stuff knowing the rules that we had in our pocket. But the main purpose of this was doing this. That was the main purpose of figuring that out. Okay? So just like we've been doing the past couple ones, you might have to figure out other things in here by algebraically rearranging these things. Algebraically take your, so my advice to you, right, is make a generic equation, right? Do like a your angle equals your major arc minus your minor arc divided by 2. Okay? Start with this. Evaluate your circle. If you're not given a circle, draw one. Right? Figure out what they're asking for. Sometimes it's a variable statement. Right? Rearrange this equation and then determine when a good spot is to substitute and then solve for x. Usually the good time to substitute is after you clear the fraction, right? So you could just say like 2 gamma equals, your big arc. Minus your, you're supposed to be red, burgundy, minus your little arc. That's your little arc. So that's 10.9, the first part of it, okay? Now there's another scenario. That's using that is if two intersecting tangents. Now, but what happens if a tangent comes in? Let's zoom in on the circle down here. We have a tangent that comes and zooms in. Hold on. Okay, I got a circle. Tangent comes flying in, like say from like the top. Comes in, zooming in this way. I'll cover this one. Might have a different orientation. Comes zooming in this way, right? That's our tangent. Purple. Okay, and then we have a sector come flying in. Our sector is going to be, let's make it blue. Unless I have another color. I don't. At least I had a green one. Pink one. That's fat though. All right, so I'll use orange. Okay, and then I have a sector flying in here. And oh man, the sector makes two arcs. Right, that's my sector. And then I make a little center point here. And it's like there somewhere. That's a good center. Okay, and then I have 2 points there. And I don't need to make another point to identify different arcs. I'm going to call this point C again. And I'll call this point A, B, and D. And I'll call this point P all the way out here. All right, and from there, let me just take a second here and get everything set up. Okay, so from here it makes 3 arcs. Okay, but there's only 2 that I'm concerned about. All right, it still makes a major and a minor arc. You can disregard one of the arcs that it makes. Okay, it makes a bigger and a smaller arc. Okay, so one of them is, we're gonna say, what did I use last time? Okay, the bigger arc here is the outside arc, the one furthest away, or on the other side of the circle from the point at which the tangent and the secant intersect. So So this one is on the opposite side of the circle from this point, where the tangent and the secant intersect. I'm gonna write the secant here. Okay, so from where these 2 points intersect, this line, this arc AD, I don't need to call it a major arc because it's not, right? Though it doesn't have to be, right? And it's encompassed by angles ACD, right? This angle, and we'll call that angle, I don't know, I don't need to write that. I did though, sure. And we'll call that, we'll call that psi. No, I didn't call that psi last time. I'll just call that nothing. I'll call that nothing. I'll call that angle ACD. Okay, and then this angle, I did my central angle last time. That's what I'll do this time too, to be consistent. So my central angle this time, I made it in blue. I'll make my central angle in blue this time as well. So my central angle this time is right here. Right here's my central angle. Okay, and I'm going to call that again psi, be my central angle. And that central angle is encompassed by, I used red, by ray AB. Should have used blue, but I used blue for my line that I'm trying to figure out. This is my so that is the angle in question, an outside angle. And so it's effectively going to be the same thing. Oh, I got to name it. This is arc AB. This is arc AB. And this is arc AD. Right? It doesn't go all the way around to AB, so I don't need to name it anything different. It doesn't intersect D and go all the way to B. Okay, it only intersects, it only goes from A to B, but it's still the bigger arc. Okay, up here we had to use a major arc because if I didn't rename it something, it'd be AB and AB, right? But I had to give it another name because I had to differentiate between the big arc and the small arc. Down here, I don't have to do that, right, because it has a third arc, this third arc segment, okay, that's not identified, all right? So, to find this line segment here, it's going to be the same thing, okay? It's going to be my big one, in which case here it's just AD, instead of AZB, which I named this one Z last time, right? It's just AD. Maybe I should name it Z this time. Whatever. Minus your smaller one, minus AB, which is red, minus your AB, divided by 2. Okay, and that's that simple, right? So say this here was 190. This is 190, and we'll say that this is we'll say 80. Okay, this would be equal to 190 minus 180. correction, 80 minus 80 divided by 2. So that would be 110 divided by 2. So this angle is 50 degrees. So this angle here would be 50 degrees because it's its vertical angle. And then this angle would be 130 degrees over there. Okay. And then remember we have this inscribed angle. Let's say I had, I don't need to say I had it. Say I had this angle here, right? It's already made a point here and here. Okay, and then I had this angle here. This line here, excuse me. And then I have this angle, omega. It's an inscribed angle. Okay, I wanted to figure out what this inscribed angle is. It's going to be half of what this angle is. What is my angle? What is this angle going to be equal? Well, this is going to be equal to my corresponding arc, right? So omega is going to be equal to AB, which equals 80, right? That was just something I just made up, right? And then, so that's psi, that's my central angle, and then omega is going to be 1/2 AB. Which equals 40. I don't know how I did that again. No, which equals 40. All right, so there you go. So that's how you do that one. Now a couple variations they could do for this, right? And again, they could give you one of these, and you'd have to algebraically rearrange just like we did the last one. They could give you this, right? And then you just have to recognize that these are a linear pair, and then algebraically rearrange and figure out this stuff. They could give you this, right? And then you'd have to jump to that, which would make you have to jump to this, right? Which make you have to figure out all this stuff, right? They could give you this, right? And then you'd have to recognize, they could give you this, and then they could give you one of these, right? And then you'd have to recognize that, well, this is a whole circle, so this one is going to be this plus this minus, and then take that sum and subtract it from 360, and then you'd be able to figure that out, right? So you just have to understand and combine all these relationships that you know about triangles to figure out these things, okay? So that is 10.9. Again, the biggest relationships that we're trying to get away from here is this deal, right? Again, you're just looking at this concept. Over down here, it's going to be you could even say something like your angle is going to be your arc that's opposite side minus your same side divided by 2. All right, that's that is the relative to the intersection point, right? If that's the way you want to think about it, because the side that it intersects on will always be the smallest side. So anyway, hope that helps out. If you guys have any questions.